This is the third video where we're trying to determine the speed of light in water. What we've already done is sent light along these incident rays. We've traced out the refracted rays and measured their angle with a protractor. Now we're going to use this formula, n equals sine I over sine r, to actually figure out what the refractive index is in each of those scenarios. So we're going to take the sine of I1, which is 20 degrees, over the sine of R1, which is 15. And we're going to take the sine of I2, which is 30 degrees, over R2, the sine of R2, which is 21. And then we're going to take the sine of I3, which is 40, and do calculate that over the sine of R3, which is 29. And we'll do the sine of I4, which is 50 degrees, over the sine of R4, which is 36. Okay, and we can plug those numbers into our calculator here. Okay, so hopefully you can see this okay. So sine 20 degrees equals 0.342. The sine of 15 degrees equals 0.259 rounded. The sine of 30 degrees equals 0.5. The sine of 21 equals 0.358. The sine of 40, that's going to give us 0.643 rounded. Sine of 29 is 0.485. The sine of 50 will give us 0.766. And the sine of 36 degrees will give us 0.588 rounded. So now we're just going to take these fractions and divide the denominator into the numerator. So 0.342 divided by 0.259 will give us 1.32. For the second one, 0.5 divided by 0.358 gives us essentially 1.4 when we round that. 0.643 divided by 0.485 gives us 1.33, and the last one, 0.766 divided by 0.588 gives us 1.30. Okay, and to figure out exactly what the refractive index is based on these sets of data, we'll average these. So we'll actually go to another video, average them, and then do an extra calculation to actually figure the speed of light in water.